All right. Well, welcome everyone to virtual tour of the Lakeside Passive House LEED Platinum Net Zero Passive House project. I'm always excited when we get to do a training or a webinar or a session on on our certified projects. So Green Home Institute, we're a LEED for Homes provider. We oversee green building certification and help ensure projects meet the goals we talk about every week here on our sessions. Now we get to see them in actual action. And so, what's really exciting about this project is really not one, not two, not three, but really four different member GHI member companies coming together all at once and really making this happen. And we've got the certainly the core members of that group here today who I'll introduce in a second. But before we get started, I want to remind everyone and thank them for our sponsor, Build Equinox. You know, traditional ERVs and HRVs provide basic ventilation, but often lack protection against airborne threats like seasonal flu and wildfire smoke. Introducing the Serve, an advanced indoor air quality management system. It offers energy recovery ventilation along with enhanced protection for an intelligent air management, continuously monitoring CO2 and VOC levels, ensuring that ventilation is only needed when those levels reach certain thresholds. It has a high efficiency heat pump that recovers energy from exhausted air, preconditioning and dehumidifying, and operates in recirculation mode, purifying the air in the home when ventilation isn't needed, along with supplemental heating and cooling. Has optional UV light, and again, smart technology that's monitoring air quality as well. So you can head over to buildequinox.com and learn more about how the Serve can enhance your project or your clients. They also have the Serve 1000 for institutional or commercial projects for a larger volume of air. All right, so this session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We're a small team, and I am the education manager here. My name is Brett Little, and I will be your moderator today. This course is approved for all five CUs under our Certified Green Home Professional designation, all five pillars, LEED AP, and many other CUs, including AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. And you can check out that Passive House code at the end to access that when you complete the course. So, with that, I am super excited to welcome back our speakers here today. Mark Miller, who was architect on this project, and Paul Abueva, who led construction. And I say welcome back because I believe this is now maybe second or third time on our show for both of you who had been on previously talking about this project throughout its construction phase. So now the project has come to conclusion, and we can go through, how it's been going. So Mark, Paul, welcome, and please take it away.
Thank you. All right, great. Well, welcome everybody. My name is Mark Miller. I'm the architect on this project. It's glad to be with you here. I'm in Evanston, Illinois. I am a green architect here in the Chicagoland area. I've been studying sustainable design from the mid 80s when I was at the University of Arizona, before it was fashionable to be a green architect. And it was really exciting to get connected with a homeowner on this project who, it's not every day someone knocks on your door and wants to do a project like this to really push the envelope and make a super high performance home that was good for the planet and good for the environment and reflected the homeowner's values. So we're going to take you on a little journey today on the process from beginning to end. The homeowner had lived next door on basically a ranch home, and over the years had kept trying to upgrade its energy efficiency. But it was a slab on grade home. It's too late to insulate under the slab. So at some point, the property next door became available, and she jumped on it and came to Paul and I to do a two-story aging in place home that had a guest room and project room and office on the second level. And the home was to support her joys and rituals. Another requirement was to make it Passive House certified, net zero, reuse as many materials as possible, and to kind of be a beacon in the southeast Michigan area to inspire others to live more gently on the earth, and that there to announce there's a better way to build. The last requirement was to do a sloped roof because in this Kalamazoo area of Michigan, this is the snow belt. They get a lot of snowfall over the winter. So when I first came to the site, I was like, oh, I'm not sure we can do this. The beautiful views to the lake are off to the north and the east. So all the windows want to be on this side of the house, but the sun that we want to capture to get our free heat was to the south. So a big challenge was to um, facilitate both of these needs in one house. And so, one of the first things we did is we did a solar pathfinder to see how much sun we could capture on the property. It was heavily wooded, as you could see on the photo on the left. And as you could see, those trees on the left of the pathfinder are blocking out quite a lot of sun capture. And on the right, we had some pine trees that were also doing it. The middle of the day was pretty good, and it turned out one of the deciduous trees needed to be removed. So we did take down a few trees on the site to accomplish what we wanted to accomplish. But those materials would get to be reused. Now, we also made a model of the trees and their heights on the site. And if you look at the house, the round house, and to the left was a detached garage that was going to have a shed roof, and we were going to load that up with solar panels. So our model was showing us where the brightest spot on the property would be. And that garage location turned out to be the best spot for our solar gain. And then here, the couple of trees that had to be removed went to a local mill, got cut up and kiln dried, and we use that for the hardwood flooring and cabinetry in the house. And through modeling the project with the help of our friends at Tom Bassett Dilly's office, who modeled the project for us, we were able to do enough tweaking and window locations and get decent solar gain on the south second level of the home where we met Passive House certification levels. Now, as I said, the house originally was going to have a detached garage. And then just before we were ready to break ground, the client came to Paul and I and said, you know, guys, I've been thinking about it, and with the Michigan winters we have, having armfuls of groceries to go from my garage into the house was not sounding so appealing anymore. So the order came in that we were going to get rid of the detached garage and attach it to the house. And we ended up lifting the house up and having a basement level garage. And I'm happy, happy this came along because it really allowed the main house to be focused on without the competition of the detached garage. It simplified the site quite nicely, and we still use that area for a ground-mounted solar array. Here's the site. You can see our home. You can see the solar panels. Originally, were going to be over the driveway leading down to the garage door. And we are as close as we can get to the shoreline of the lake, about 50 feet. So now putting a garage in the basement is a concern to me as the architect because we're going to hit the water table soon. And so Paul and I decided we would raise the house several feet up from its original first floor location. That gave us a couple of feet extra of peace of mind before we hit the water table. And then we also I was quite concerned about the long driveway we had to get from road level down to the basement level. And this long driveway was going to collect a lot of rainwater. And so between the lake threat and the rain threat, we were very concerned about keeping the garage level dry and not becoming a bonus swimming pool for the client. So we achieved that in a few ways with a French drain that was put in the middle of the drive. The driveway slopes about 30 feet down away from the garage door, creating a reservoir. So on a very heavy flash flood of a rain, water can pond for quite a while before it approaches the garage door. And then we've got nice linear drains on both sides of the garage door leading to a sump pump. So we did a belt and suspenders approach to keep things safe. Another important aspect of the home is its aging in place um, design. And we see this in several ways. First, the first floor is where all living can take place. So kitchen, living room, dining room, master bedroom and bath, entry, clothes washing is all happening on one level. Everything's barrier free at all the entries and exits. The doorways are all around 36 inches. And there is also, now that the garage is in the basement, should mobility become an issue, we have pre-framed a cutout. You could see it in the middle of the circle on that photo on the left. So we could knock out a small square in the floor and install a lift. All the power is there. It's ready to go. So everything's been nicely thought out, including a barrier-free shower in this instant. So that all worked quite nicely. Now, I'm going to take a small detour here. GHI, all the webinars that we've seen over the years that we love so much are talking about how to make healthy homes. And these homes are, we always talk about using eco-friendly materials and using ERVs for fresh filtered air, filtered water, using materials that are low or no VOC, and even we talk about radon mitigation and a variety of other topics. Well, what I want to propose to you today is that perhaps if we zoom out a little bit, that health really has to include our mental health and our spiritual health. And if we take a deeper look, our body is what relates our being to the environment. Our mind and our soul is what connects us to other people and relationships. And I'd like to propose that our spirit is what connects us to the spiritual dimension of life, which makes a complete person. Now, if you have trouble with the word God, we can use spirit or love or any other word that you find appropriate for yourself. Now, there are many disciplines around the world that understand this importance of health, including mind, body, and spirit. One of them is yoga. So if you've attended a yoga class, you probably know what I'm talking about. We stretch the body and do different poses, and the idea is to open up our body to receive this life energy that is all around us for our health. If you ever had a professional massage or acupuncture, you know that an acupuncturist is using needles to help open up constricted pathways in our body that aren't allowing the free flow of this life energy through us. And it is believed, at least in a third of the world, India, China, Japan, Korea, this is an everyday term. This is common knowledge, just as common as drinking water and breathing air to these cultures. And it is just starting to catch on here in the States. But I've been a student of spirit since college, as well as our client has been. And so this is an important element to us. Now, to show you how architecture might be able to help connect users to this energy. This is a acupuncture center that I did in Chicago many moons ago. And you could see the entryway is very open to the sun's rays. And when someone's waiting to get into their appointment, they're basking in the sun and starting to feel that connection to nature. When they come down the hallway to get to their treatment room, you're seeing curved shapes that are metaphors to the flow of this energy coming into the acupuncture center, through the hallway, and then the curves of the walls are helping redirect and guide this energy into the treatment room. So one of the exciting things here that the architecture is doing, it's supporting the acupuncture practitioner in doing the work they're about to do, which is to help connect um, the client's body to better receive this connection to spirit and to health and healing. So, Mark, why is this important to connect to spirit? Well, I'm glad you asked, Brett. So, it's important because connecting to spirit automatically gives us this instruction booklet on how to live healthy, how to have intentions that lift up everybody, including ourselves. So, love, stewardship, empathy, community, equity for all, these are all spirit-based values. Now, what happens if folks are not connected to spirit? Well, that instruction booklet seems to only affect me as an individual. So, love without spirit is hate. Stewardship without spirit is destruction. Empathy without spirit is self-centeredness or ego. Community without spirit, we treat people as others or enemies. And equity without spirit becomes greed and scarcity. Now, can we see samples of this all throughout the world? I think we can. Can we see it in our own country? Absolutely. Can we see it in our own communities? Of course. And can we even see it in ourselves? Yes. And I would like to propose, that our time on this planet is to work on one spiritual evolution to go from a consumer to one of a steward. And our environment is in dire need of this fact. So, as much as we talk about climate change, I still think it's kind of a polite term. And I think we really need to zoom out and look at the bigger picture and say climate change is a result of a lack of people being connected to spirit. So, I'm hoping you might ponder that. So, what I'm showing you now here, this is a slide 38 years ago when I did my senior thesis in architecture school and was understanding this idea of seeing how architecture can help connect people to spirit. I came up with these themes, and many of these themes are being used in the project that we're going to walk through today, especially connection to nature, flow, this key energy, breath is winds and nature coming in through on off the lake into the home. And so now let's go in and see how these ideas come into play conceptually for the design of the home. So I started with a circle, which is a universal symbol for wholeness and completion. And I sliced that down the middle and offset the two semicircles. Now, this allowed the curved forms to help bring people into the interior of the home, and it also, those curved shapes help bring people and awareness outside of the home, creating these nice in-between zones, both at the entries. Also, the two flat walls you see are the only flat walls on the exterior of their house, which are indicating these are the points of entry, and this is where the spirit and energy that we're talking about are meant to come into the home and circulate all through the rooms of all three levels. So we separated the two semispheres by 12 feet, and these two radius points, R1 and R2, is really what set up all of the construction. I mean, if I had a nickel for every tape measure that got put on those two radius points, I'd be a millionaire. And this is how we set things up. There's a foyer entry on the right at the front door there. Guests coming in don't see the rest of the house until they're invited in. All of the rooms that needed to see the beautiful lake view are on those sides of the house. So we have the master bedroom on the right. We have the dining room looking through the screen porch to the lake. We have the living room and even the kitchen looking across the living room out to the lake views. The few rooms that didn't need or demand lake views, the utility room, the stairwell, the foyer, those, as you can see, are on the part of the home that didn't have the beautiful lake views or needed them. Then we go upstairs on the curved stairwell. The theme is like a tree trunk, and all of our utilities are running through the center circle you see in the house. One of the requests was to have a two-story space and a loft, if you will, on the second floor looking down. And you can see the Shea Lounge there at the top of the screen, and the balcony has the best views in the house. 180-degree views of the lake and the trees. And the most interesting thing about the house design, unlike living in a box home, you never see the outside of your house when you're inside of your house. But on this particular design, sitting at the balcony, reading your book or having your morning coffee, you can see the outside of the house while you're inside of the house. And so it starts to mesh interior and exterior space together and create an illusion of the walls becoming more invisible. There's also an office to the left, project room, guest bedroom, and a game room, and an outdoor balcony on the second floor as well that is to the south. And we're going to walk you through this in more detail, but I just wanted to give you a quick lay of the land. And then in the lower level, just the conditioned space is the stairway heading down in our future lift area and utility room. Those are in our thermal envelope. We wanted to leave the entire garage and storage outside of the thermal envelope to minimize our energy demand. And so this is what we come up with. So the concept in Paul's good hands turns into a construction site, and as it goes up, it turns and finishes into a beautiful home. And we can see the concept that we started with reflected into the beautiful forms of the roof and the walls below. So now we're going to walk through the home, and you'll get a sense of this flow that we're trying to achieve. This was on a heavily snowy day, so you're seeing some snow on the solar array. We're approaching the foyer. There's a place to sit outside at the entry if you're waiting for folks. Here we are coming to the foyer. You're in the center of the house here. This is a powder room, ample storage, change in floor materials. Made a beautiful wood slatted ceiling to highlight the hearth and center of the home. Now we'll come into the great room. The two-story space has no columns. We hung the balcony from the attic floor so that the first floor could be totally free. No columns to obstruct your view. Instead of seeing the bottoms of the trees, we're seeing the entire trees due to the nice taller windows that got used. The flow of the countertops of the kitchen flows into the utility room. There's a drying rack that lowers from the ceiling. And the master bedroom's on the east side of the home. Large door. These windows look out to the lake. And these are tilt and turn windows. Master bathroom also has a higher silled window for privacy out to the lake. Barrier free into the shower. Just enough space to do what you need to do. It's very efficient in layout. Powder room has a hand washing sink built into the top of the tank. I was in Japan this past summer. Every toilet there has the same function, which is a great way. So the water refilling the tank allows you to wash your hands. You're conserving water this way. Now the space flows up to the second floor through our open riser staircase. Light streams down below. Built-in bookcases, which is a nice little trick we accomplished coming up to the upper level. There's the project room, views out to the lake, custom handrail. The homeowner found an artist, local artist, to do that. Came out wonderfully. Views past the office. And then, of course, the best seat in the house there. And we turn this way to head to the guest bedroom. Same curved hallway as downstairs. All our mechanicals are to the right in the main circle. And then this is the game room, quote unquote. And we're capturing a lot of south sun here. In those windows you see there over the stairwell is our main solar gain for the project. Hotel style guest bathroom. So when her many guests come over, if someone's in the bathtub, it doesn't have to prevent others from brushing their teeth and getting ready for the day. And then a large window out to lake views also if you're soaking in the tub. And as the master bedroom below, so does the guest bedroom above. Two windows looking out to the water. Built-in storage. There's a closet behind the door. And just enough space for the bed. And then we go from the first floor down our curving stairwell, curved wooden handrail, which was a trick. And now you'll notice again, the floor is flush with the garage floor, barrier free. We have our Tesla battery system next to our high performance hot water heater. And then there is room for two cars and all of Kate's fun toys. And then there is a tornado shelter built in the back here as well for safety. And oddly, this has been a request more and more from my clients these days is the tornado shelter. So there you go. Give you a quick overview of the house. Construction wise, we use poured in place concrete walls. We're using TGAIs on the floors for the first floor and the attic floor. We're using open web floor trusses for the second floor to run all our mechanicals through it. And then just one thing I wanted to mention, working on this project is just bringing me first full circle around. I remember as a kid getting my first solar calculator, and I was so excited, and it really struck me like, wow, this is amazing. This is a product that doesn't need to be plugged into the wall, and just the sun alone is providing all the energy that this product needs. Like, this is the wave of the future. Like, everything now that we make has to start following this model, this inspiration. And I'm happy to say to you, all these decades later, that we've designed a house that also is just using the pollution-free energy from the sun to provide all the energy needed to run the house throughout the entire year. So with that, I'm going to pass this on to Paul, who's going to go take a deeper dive into the construction of the house and all the passive house elements there.
Thanks a lot, Mark. So as Mark mentioned, my name is Paul Bueva. I'm a builder of energy efficient homes. We focus on environmentally conscious designs and universal accessibility in all of our homes. I wanted to start the presentation here. I'm going to give you a brief montage, just kind of the construction process, and we'll discuss a few details, but I also will take some time here for some questions if anybody's got while this is rolling, because it does take a couple minutes to make it through the photos. So with that, let's get this going.
Yeah, so Paul, and Mark, the question, and Mark, you kind of alluded to it at the end there, but the question that kind of just came in is resiliency. Um, to the climate. And so obviously neither LEED nor Passive House have specific call outs for resiliency. I know LEED did at one point and then they kind of threw it out. I think LEED version 5 is going to fix that. Now, of course, they don't call them out, but they're built inherently, especially Passive House in many ways. So I think the question then, you mentioned the tornado shelter, but going further than that, just general resiliency to the home, if that was thought through about what we can expect, here in West Michigan when we run the climate risk models, which is required in our Green Star program, for example, we see very heavy winds. And when we look at heavy winds, we look at it more from the, less the evacuate, there's a tornado, and more from just those things knocking the home down, right? Degrading the life, the durability of the home. So, and then we of course see, most likely intense cold waves. We had one of those intense heat waves coming up. So just with all that, what kind of design in here is being thought to sort of resist these climate elements that are most likely coming our way?
Yeah. I mean, obviously the tornado shelter is a good plan. I mean, most people here in Michigan at least put basements in their homes because it is a concern. But I would say that from a resiliency, say potentially against wind or rain, other nature events, a round house is actually very strong in winds. You don't have that many flat surfaces on this house that are going to take the brunt of full force winds. The other thing too is that it's primarily it's not really a hip, but you have eaves on the majority of the roofs. So its ability to sort of shed that or deflect the wind there is also uh, is a benefit. And honestly, the way that the two halves, although they're offset, kind of adjoin each other, they actually provide additional strength to both halves. So in other words, if you could picture wind pushing on the one gable you see, it's pushing back against the curves and pulling against the other curves. So it's quite a strong structure overall. Um,
Yeah, the diaphragms of the floors are really supporting that curved shape. So it is a very rigid, resilient structural form. And also, we stopped by to visit Kate over the holidays, and she had mentioned how quiet it is with the heavy winds coming off the lake because they literally just go around the round walls. They're not banging into the windows head on. So I'm pleased to say that the form's really working great.
yeah, do you have any other questions then about that? No? Okay, then I'll keep moving forward on this. I did want to revisit sort of the cross-section envelope that Mark had alluded to previously and just go over a little bit more of the specifics of it. So as we mentioned before, this is a very highly insulated structure. We were shooting for an R94 ceiling value, on R54 wall value. So that was a 14-inch thick double studded wall and an R56 in the floor joist system that's above the garage. We also utilized triple pane windows throughout the house. Specifically, Passive House requires certain windows that are certified by them to be used, and it's one of kind of the sticking points to reach that design. Also, the entry doors were very thermally efficient as well. I have another video here that kind of demonstrates kind of how it goes together. So starting from the foundation, uh, it'll give a brief overview of kind of how things went together. So um, as you can see from the basement and working its way up to the first floor, it's very complicated framing design. And I don't know that this would be it would be extremely difficult to frame this house without the benefit of modeling. So one nice thing is that our company produces models of all the projects we do. And it allows us to identify difficult framing problems or insulation problems. Also, it allows us to sort of plan out our systems. So where we want to run duct work, how we're going to get our plumbing into the house. Um, I can't imagine not having those levels of detail available to us um, at the beginning. I think we would have run into a lot of issues. Particularly, the design is rather compact, and so there aren't really any chases that were built into the house to accommodate ductwork and plumbing. So really seeing that in advance through modeling allowed us to plan that out. There's choices of the floor system so that we could accommodate the ducts so that everything could be hidden. Um, as you could see previously from the brief photo montage, in order to get the curves, I mean, this house is truly round. It's not segmented. Everything in it is really curved. And so much of it was CNC'd. All the wall plates, the window bucks, the um, fire breaks that we utilize to separate floor systems, they were all CNC'd. And, Mark mentioned briefly as these radius points, and then therefore we could calculate radiuses so that we could produce CNC drawings to ship to manufacturers. So from framing materials to the railings to even the wood flooring and numerous other materials could be produced efficiently and effectively off-site without having to try to figure it all out in place. So this brings us to this process of super insulating and uh, a house like this. So as I mentioned before, the main exterior is all a double stud frame design. Now, my company's had experience in designing double frame houses, although trying to adapt this to curves was a whole nother animal, a whole nother challenge. We prefer the double stud because it allows us to use dense pack cellulose and avoid a lot of thermal bridging throughout the design. So our focus is to really only try to use foam where it's absolutely necessary. So from a couple of these photos, you can see that we did use it as an air sealing detail. That picture up in the upper left corner is showing the underside of the uh, attic floor. And so because that is our air barrier, we needed to be able to seal that up. We also did use foam. A good example of it is this attic access hatch. So the attic access is inside the house. And when you have an R94 ceiling, you need an R94 attic access hatch. So we designed this one, what we called the cork. And it's rather heavy. So we actually have uh, uh, support struts on it to help lift it. And it's also gasketed, actually double gasketed. So this top lid closes, and there's actually there's a drop down stairs from below, an attic ladder that is also gasketed. And when it closes up, and it has its own insulation. So the combination between the two insulation layers allowed us to get to design this. Some of the pictures down in the lower right corner here will show the process of insulating for dense pack. So we needed to be able to put on what we call InsulWeb. It's a membrane, a mesh membrane that goes on the wall that we can now have hold all our insulation in. In order to help it retain the curved shape too, then everything was cross-strapped with 1/2-inch plywood that was bent to the radius and helped hold all that insulation back. So a key part of a passive house is this notion of air tightness value, more so than anything else, whether it be LEED or any other building standard. And it's one of the things that makes the passive house the pinnacle of energy efficiency in terms of certifications. So a key to the air tightness is that you have to pass a metric of 0.04 CFM per square foot based on surface area. Now, that's not a metric that people are very familiar with. Most people, when you're doing blower door tests, you're more likely to see a number that would indicate an air changes per hour based on volume. So in that case, this translates to about 0.6 air changes per hour, which is a very extremely tight house. Fortunately, having had experience in this, we've designed pretty much every home we've made since 2016 has been able to attain this level. And so we have a lot of experience in how to get these houses that airtight. The primary method that we rely on is this zip sheeting that is visible in some of the photos. That taped provides our primary air barrier. You can see we also use a series of gaskets for penetrations throughout it. I've included in here this lower right corner to show that although we are using these tapes and gaskets, we're really using very simple methods. The key is just that they are taken care of during the framing process so that we don't have areas that we can't reach later and address. So nothing's taken to chance. We already know where we want to put these barriers. My framing crew is very experienced at this and knows where to apply these during the construction. In fact, we air test the house twice during the process. So typically you might have the house tested at the end to find that value, but we'll test right after framing prior to insulation and prior to drywall so that we can identify if we happen to miss anything and tighten it up. I'm happy to report that we were already at passive house levels prior to at that first air testing value. So another thing that we do is that we sort of do a belt and suspenders approach on this. So some of the viewers may be familiar with the idea of an airtight drywall approach as a method of air sealing a home. We pursue that as well. So the photo that's at the lower left kind of shows the detail of that, where you're applying beads of sealant to ensure that the drywall is sealed to the framing. And then also some of these photos, particularly the large one, kind of shows just how we have duct penetrations that are going into this attic space, or just the amount of foam to seal penetrations that are going into there. Also, if you look on the left edge of that photo, you'll get an example of the airtight boxes that we use to vapor seal all the electrical penetrations. So it does take a very concerted effort, but it does not need to be that difficult or that expensive to do it. It just needs to be something that is thought out and understood. I provided an example of the window installations that we do. And there's lots of products on the market now, various gaskets, things like that. But really, we rely on sealants, on flexible caulks. So a traditional method of installing a window might involve putting some low expanding foam in between the frame and leaving it at that. In this case, we do that, but the foam serves more of as a backer rod almost. We fill up the majority of the space, but then foam's not doesn't have the longevity that the sealants will, and so then the sealants are applied over the top of that to ensure that we're getting a really good seal. And in fact, in this case, because of the way the windows were installed, there's a sealant both inside and outside on that detail. So this brings us to the windows of the house. So as I mentioned before, Passive House has some strict requirements on their windows, and only certain manufacturers are certified to produce Passive House windows. We also tuned the windows to take advantage of passive solar heat gain. So the large diagram here kind of indicates which windows on the house were high solar heat gain coefficient windows and which were low solar heat gain coefficient windows. Now, it's easy to think of if the house was just square and you knew where your northeast, west, and south sides are, but with the roundhouse, it's a little bit more difficult. So it took a little bit of modeling to try to decide on which ones would make the most sense. And even in fact, too, there's some that might seem a little odd, but it was necessary because, say, for instance, there's a glass door coming off the balcony that if it was a high solar heat gain, it would just overheat that room. So we have to be careful about just automatically assuming that we want all our south-facing windows to be high solar heat gain and all of our north windows to be low. There are other considerations in some of these. I included a chart of the glazing inputs. It's interesting, I guess, in the sense that it gives you a sense of just how thick these windows are in a passive house, and just how much differentiation there can be between the solar heat gain coefficients of the windows. Also, we provide a U value there, and so even typical double pane or even triple pane manufactured windows from other companies, say Pella or some of the other major manufacturers, Marvin, Anderson, They might get to around 0.17, 0.18, but these glazings are down to 0.12, 0.13. So that's just that little bit farther that a passive house certified window goes. Also, a passive house certified window is better air sealed in general, and it's another requirement for it. So we wanted to talk a bit about the energy recovery ventilators. Passive house, a big thing about that too. Another key point is the air quality. You are required to meet EPA Air Plus certification for it. In this case, we use the CERV from Build Equinox. You can see it as labeled 1 in the first photo. They also provide a GeoBoost function for it that helps offset. It's a ground loop system that helps provide additional heating and cooling to the incoming air. We do tie in, did a little bit of different things here. So in this case, we didn't have a traditional kitchen exhaust hood. We had a recirculating hood, but then there is an ERV exhaust vent that is triggered with that to boost the ERV and exhaust that air. Key being for that is that we just have to have enough distance from that vent to the recirculating hood to ensure that we're not actually sucking things off the stove without passing them through the recirculating hood first. Another thing that we do is that we use manually activated timers to control boost for humidity and smell within the bathrooms. So in the third image there, I'm showing the location of the humidity sensors. So they're automatically activated the boost on the ERV when you're taking a shower, for instance. Or if you are using the bathroom and you need 5 minutes, there's a boost timer that's conveniently placed where you can hit low increments, 5 minutes, 10 minutes, and have it shut that boost down after you're done. I included this slide here of relative humidity. I'm not going to spend a lot of time on it, but basically what it indicates is that the ERV, that's the blue line, has a great moderating effect on controlling the humidity relative to the outside humidity of the air. And likewise, the ERV also has the ability to moderate the temperature that's going on in the house. So the blue is the inside temperature. The orange is, although it's the temperature that's after the GeoBoost, and the green is the actual outside temperatures. So you can see that on the in the winter seasons that the GeoBoost is warming the air significantly prior to it coming into the house. And then also during the peak of summer, you can see that the GeoBoost is cooling the air to a certain extent prior to it. This brings us to the HVAC equipment. We use mini splits in our designs, and we have for quite some time now worked with vertical air handlers. So we have, many people think of mini splits as being sort of the wall mount or ceiling cassette designs. We use fully ducted units, and that's what was incorporated in this house. In this case, we did a downdraft design of the system. You're capable of switching sort of the orientation of the machine, and you can see that because the ductwork was sort of running in the second floor system primarily, and that's one reason I mentioned before about having to design the floor system specifically to be able to accommodate this ductwork. The hot water systems in the house, we chose to go with a hybrid water heater from Rheem. In some of our research, we were concerned about the on-demand electric heaters being unreliable or not having the longevity of potentially a tank heater. There also are other issues provided with the on-demand. Sometimes there's delay on it. If people are familiar with a hot water or a cold water sandwiches, where one user uses it, pauses, the next user fires it up, there might be a slug of water in the line. So it is nice. And even these on-demand heaters, they're putting small tanks in them now to overcome this problem. One interesting thing about the photo over here is we chose to put the Tesla batteries in the room with the water heater. Because of the heat that those battery systems are producing, it just provides a way of us taking advantage of that heat and using it to heat our hot water there without losing it. I've just provided a brief overview of the solar panel and battery backup system. In this house, we put 32 solar panels in that were 370 watts. So we had a total capacity of 11.84 kilowatts. And we put in a 27 kilowatt battery backup system. Um, this, on my next slide here, this demonstrates the production of the solar panels versus the consumption of the house. And the green line represents the cumulative net production. So in order to be net zero, you've got to have that balance throughout the whole entire year. And so as this chart demonstrates, you can see that we're getting like high production as based on the orange in the summer, and we're banking away basically energy that can later be used in the winter when the consumption now exceeds the production of the panels. I'm running a little short on time. I might blow this one over, but it just is meant to demonstrate there were a lot of other green features in the house that just don't even come into play regarding the systems. The use of the wood, our recycling, our reduction in job site waste. Most people find it fascinating that we can manage to build an entire house like this and only produce a little over 32 cubic yards of landfill waste. The house attained numerous certifications. So we achieved a LEED Platinum certification, the FIAS Net Zero certification, but along with that, the Energy Star and EPA WaterSense or EPA Indoor Air Plus were required as a prerequisite to FIAS. And we also did pursue the DOE Energy Ready certification in WaterSense. And then I just wanted to briefly go over some challenges of FIAS. It's a very difficult standard to get to. As shown here, there's only been 62 single-family homes that have managed to be certified under the FIAS Zero so far. One of the difficulties in that's the degree of testing requirements that are needed to meet that. So your HVAC and your ventilation systems have to be stringently tested. And I feel that that's probably a reason that although they register many houses, you can see that almost 50% of them don't manage to make it. And I'm guessing it has to do with the fact that at the end of the day, they're just not meeting the standard. So this brings me to my last slide, and it's just a demonstration of this house. It's been lucky for both me and Mark to have achieved numerous awards. We were recognized by the USGBC of West Michigan as their Innovative Project Award in 2023. We also, this past summer, were recognized as the Outstanding Single Family Home Award from LEED. That was a global award. We had other competitors or other entries in that award that were from Colombia, Germany, other countries around the world. And finally, we just received an award this last December that was from the USGBC of Michigan, recognizing local leadership for the Quality of Life Award. With that, let's see. I guess I'll open it up to questions.
Hey, thanks, Paul. Thanks again, Mark. Yeah, before we get into those questions, just a real quick reminder that yes, this session is being recorded, so you can please check anything you missed, or if you have to go early here, you can come back and watch the rest. You can share it with friends, colleagues, post it on social media, you name it. Watch it again on our YouTube channel. It will be up in the next couple of days, so you can check back then, or you could go there right now and then click subscribe and then get an instant update when the session is posted. For those of you watching this in the future on demand, take your quiz with an 80% passing rate and you can receive your continuing ed certificate. But those of you here today, as long as you've been here for the entire approved CU hour, you are good to go. So just take that survey that pops up either when you close out or that gets sent to you afterwards. And then check your spam over the next couple of days for certs at gutenbergcerts.com. And you can log into your account there and access your certificate. And before we get into all those questions coming in, just a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our members. We have over 400, hoping to get to 500 by the end of the year. So help us get there, and our top tier sponsors who make many of these products that are going to help projects achieve and surpass LEED Platinum Passive House, such as Rheem, Build Equinox, Serve, Panasonic, Mitsubishi, Tamarack, many of them who make the products to achieve the goals and outcomes. So, I wanted to kind of take a step back to the design considerations. There were a lot of questions that came up around that. Um, but again, from like a LEED standpoint, from an energy and atmosphere standpoint, we're always looking at the HERS index rating, achieving that. But of course, when you go passive house, you're going much further than that. And typically, passive house projects usually uh, qualify a LEED project for all of its energy points. So I always want to make that clear to everybody that if you go passive house, you've basically taken care of all your energy points in LEED. You're a fourth or a fifth of the way there already. But there's other sustainable things you need to do that a passive house doesn't account for that you do in LEED. So, um, but the modeling side of it, we're looking at more than the HERS rating. You're really starting in that design stage. So, Mark, could you just kind of speak to the what you're really doing in the design stage when you're approaching a passive house project? And you're muted, just so you know.
There we go. That energy model becomes a great tool. We're able to adjust our values for the walls, ceiling, floor. We can tweak the window locations, the window size, the shading of the windows. It's kind of like Superman's, vision. So, we could do all these what ifs, and then it steers us into the direction of, getting all of the systems to be lined up to hit the certification levels.
Mhm.
And then we're good to get into construction documentation from that point. But it happens very early in the process. And like I said, when I first came to the site, I was a bit worried that we just couldn't do it with all the challenges that we were presented with. But
Mhm.
we were able to get some iterations going and make it work.
Yeah. And Paul, where does from a construction standpoint, where does, your team interact with these models? Is it kind of just like, here it is, do this, or is there, conversation you have as part of that to just make sure it's possible, it's within the budget, or how does that work out?
So this being our first passive house and being the first one that sort of had to go through this pre-registration process and have to do this modeling for it, we have a sense of what um, we build numerous LEED houses
Mm.
and produce very energy efficient designs on those using a similar double stud, but we don't have the modeling information.
Yeah.
So we we project kind of where we hope we're going to be at with the
Yeah.
performance of the house at the end of the day. But having, as Mark said, that ability to tweak it and kind of really fine tune it and test it, it's invaluable. That being said, sometimes the modeling will tell us, well, in this particular instance, we had to have a very thick wall because
Yeah.
of the amount of glazing that was present in the design. Normally they'd like to see less percentage area of glass, which would then subsequently reduce the need for as much insulation. And sometimes then obviously these choices of insulation strategies affect the frameability of the house. And so fortunately, it was a bit of a Mark had most of the design done, but he was very open to us coming to adjusting the framing designs to things that we knew that worked and provided better ways of getting the insulation in there, and also it being a very airtight structure as well.
Yeah. And oh, go ahead, Mark.
Oh, the theme is balance. You're juggling aesthetics, you're juggling energy efficiency. And I think the one thing that I hope we communicated today was that, we're trying to find where is the sweet spot amongst all these variables, where it works. We didn't, even cost, obviously,
Mhm.
more insulation, less insulation, and then is the cost, is the benefit worth the cost? So all these things are being juggled before we finally get to the end solution.
Well, and
I would like to add that. Sorry, I just wanted to add that you know we had the energy modeling done, but we also do our own modeling. As I mentioned during my portion of the presentation of all our homes, we produce 3D models of it.
right.
It allows us to be more efficient in our use. So many times we can help customers understand that we can be more efficient in the use of our framing materials or even in our calculations, where a lot of builders might potentially say, oh, I need to order this much square footage of footing, or I'm sorry, flooring.
Yeah.
We knew exactly like how much, so we don't have waste. That's another way that we have contributed to avoiding the waste that you would typically see in a house, which translates into savings.
Right. Yeah, absolutely. Um, so I was thinking about the you know, your practices there, and so what, one of the kind of questions came up around the garage, and obviously LEED really likes, they give you extra points if you can, number one, not have a garage because they want to, of course, encourage public transportation, which I know is not always practical in some places. But then, of course, they also want to encourage health, so they don't want to have, right, pollution from a vehicle or chemicals we store in a garage interacting with the house. So I think in this case, you've got probably electric vehicles, so maybe it's less of a concern there. But still, you never know who would move into the car. So how does the air sealing details you described, Paul, play out any differently in an attached garage situation, or is it really when you're doing passive house that's kind of covered, or is there any other mindfulness of what you're doing just to make sure you don't have pollution entering that might be in the garage into the house when it's so attached?
So we didn't actually, there's so many details of this house that we just didn't have the time to get into, but
Yeah.
there's actually a ventilation system that's present in the
Oh,
basement.
yeah.
So there is fans down there that
Yeah.
are activated when VOC levels are high, and we designed an exhaust so that we could create cross flow to control the air quality in the
Yeah.
garage.
Yeah.
The other thing about that being whether it be in a basement or whether it's an attached garage, one thing about using a ERV like that is that we're creating a balanced air pressure environment. The
Sure.
exterior air pressure to the interior air pressure is matched. So there is no draw. Like say, for instance, if you open that garage door from the basement, there is no pressure imbalance that's going to force that air from the garage into the
Mm.
house.
Yep.
I think, in all fairness, we also have to mention, Paul and I were both a little concerned having a subterranean garage and what was going to happen to those concrete walls throughout the year, with condensation and such. And so, one lesson learned from this project is, we originally had a window well that you could open and at one end of the garage, and we had fans by the garage door. So we had this nice cross ventilation to eliminate any possible pollutants from
Hmm.
a vehicle. And it turned out in peak summer, with such humidity outside, we were having some issues on the walls. And so we did have to, I'll let Paul tell what was added to the system to overcome that surprise.
Yeah, so we knew this might be a concern initially during the design, and so that's one reason that uh, during some of those construction videos, you see a great deal of sub slab and exterior insulation on the foundation, and that was meant to just sort of te help temper that a little bit more to helpfully prevent that. But yeah, we did discover that we during peak summer we did have some issues, and so we ended up having to put a dehumidification system into the basement there.
Interesting. Yeah, well, thanks for sharing that and bringing that up. And it just goes to show, you can't just build a home and walk away from it and, hope it is okay. You have to really monitor it, right? And make sure everything is still working out. So,
Yeah,
um,
actually, I mean, once the dehumidification was put in, I mean, it solved it, and it wasn't even that expensive of a addition. I mean, I think for like $700, to get that in there and get it wired and plumbed and
right. Yeah. The other thing, kind of continuing on, we talked a little bit about, some of the aspects that lead to the energy savings for the lead minimum energy performance and passive house air sealing. Um, but of course, with the HVAC system, and one of the parts of LEED and in the indoor air plus standard, which is required for passive houses, that for indoor environmental quality is that the ventilation standard being met. And so meeting the ASHRAE 62 and having that continuous ventilation. Now, how does that play into the energy savings of the house when you're using like a demand controlled system that you have, like the smart, ERV system? Does that, help save energy when you're using that? Does that show up in the models? Is that an aspect that was thought through within passive house design?
yeah, it's something.
Um, well, that ERV is a really smart system.
Mm,
Um, and so, and then when we added the Geo Boost, we got
Yeah.
additional energy efficiency. Plus that
And that doesn't
ERV.
mean it was geothermal, right? I always get that mixed up. That's just a boost from the ground. It doesn't mean it's a geothermal system, right?
No, it's the
Well,
design's similar, but yeah, not to that extent.
it's
Yeah.
not drilling 100 feet down and getting your tubing to go that far.
Right.
We had before we were backfilling the foundation. It was like, I called Paul like, why don't
Mm.
we just throw in, some piping in there just while we
Yeah.
can? It's inexpensive, just in case we add the geo boost. And we
Yeah.
ended up doing that, and everyone was better for it. I don't know if that answers your question directly or not.
Yeah, no, I again, it does. Yeah, just trying to get a sense for where that, because typically when we see projects, we're looking at, traditional energy recovery systems. They're just, right, they're just air in, air out, and either they're on an intermittent exhaust, so they're turning on and off, or they're just running all the time. But I mean, this system, it's
It
only
has
running
four,
when there's
it has four
pollution.
stages. Yeah, it has four
Right. Yeah.
stages because it also goes into a recirc mode too.
Right.
So it's monitoring VOCs and CO2,
Yeah.
and once it
Yeah.
hits the safe levels, it'll switch gears and run
Yeah.
even more efficiently. So it
Yeah,
Right.
I think
was a
it's
good
important to
choice.
note that with the ASHRAE standards, the house was required to meet those standards. So, but it's what the serve does is sort of above those standards. So
Right.
potentially down the line here, maybe ASHRAE could reinvestigate their need for ventilation. Um,
Yeah.
as it becomes more commonplace to incorporate these VOC sensors, CO2 sensors, other measures of actually measuring the air quality, then you wouldn't have to rely on this simple metric of saying, oh, I need to ventilate this much air this many times a day.
Right.
So when the system's initially set up for us, of course, we have to test it out to show that it can do what ASHRAE is saying it does.
Yep.
That's the requirement. But in the end, whether the homeowner chooses to operate it less than that and rely on the controls of the serve to more automatically take care of that, and then thus subsequently use less energy. The biggest energy usage which of those systems is the fan. Constantly
Right.
running the fan.
Yeah, yeah. No, and good news, I have heard ASHRAE is considering that and has to some extent as well, but they are in a new version coming out. But yeah, so my question was more of like, Passive House gets fairly aggressive on, your end use energy, right? So I just wondered if it had the ability to look at a system that's designed that way and use that in your benefit. And that was really more my question. Like, is that showing up in the Woofy models or not? So, but
Well,
maybe we don't know.
probably not. No, I don't
Yeah,
think it is. I mean,
yeah,
just the general
yeah,
effect of the particular ERV and its specifications are put
yeah,
into the model, but
yeah.
the nuance and subtlety is not.
Right. Yeah, yeah. Um, uh, and then so the other aspect of this home, all electric, if anyone was wondering about that, just to make that clear. And in that regards, there was a question just about like the cooking. Was induction stove used as a part of this home?
Yes, it's an induction stove.
Okay, great. Yeah, yeah. So that answers that question. So, and then, going back to that resiliency question that came up earlier, um, Mark, you had mentioned that this home is using its own power from the sun. And so, of course, you've got batteries, which, in the event that there's going to be frequent power outages, either due to storms or due to, I think it was just what, the other week when we got hit with that cold wave, our grid here in the Midwest almost broke a record for demand, which, at some point that could take the grid down both for a heating and a cold cooling situation. So it sounds like this house is sort of designed to buffer against that outage. Um, but in the event of a very long outage, does a home like this kind of resist the elements of extreme heat or cold? How does that play into the design?
Well, that's just the beauty of the passive house theory in general, is
Hmm.
that it takes so little to keep the indoor conditioned temperature
Hmm.
safe. And
Yeah.
so, you can light a bunch of candles and set them around the house
Yeah.
if there's no power. There are things you can do. It doesn't take much. You can call your friends over and, jog in the living room for a few minutes, and the body heat's gonna, stay in the envelope. That's the whole concept. So it's resilient in that way. We should point out, though, it is a grid-tied home. So we are relying on the grid to do some of our energy storing during the
Mhm.
summer to get it in credit back in the winter times. The
Okay.
number of batteries we would have to have,
Yeah.
it's not going to last for 6 months.
Yeah, yeah. And I didn't think it was off the grid. But you're right. The net positive of the home, if I understand, over the course of a year, it generates more energy than it consumes, right? Yeah.
Yeah,
That's
and
the bottom line.
I'd like to point out too that with that large of a battery system, with a complete power outage and with zero production on the solar panels, say for instance right now where they were covered in snow, she could probably still go a couple days, just purely running off a battery. And I mean, if you clean the solar panels off, you might balance yourself out. You might not even need the grid.
And that's with heat, correct? With maintaining the heating system, correct?
The mini split is not hooked into it, but the ERV is, and the ERV has capabilities to provide a
Right.
certain amount of heat. So it might not maintain like 70 degrees in the house, but it's definitely not going to freeze in there. And in
Right.
fact, it probably even in extreme cold conditions, just because of the insulation levels of the envelope, it just wants to hold on to its heat. I mean, I think
Mhm.
it would take days just for it to even cool off if you did nothing.
Right. Right. Yeah. So kind of getting back into what you had mentioned earlier, Paul, about the great work you're all doing with waste diversion, construction waste mitigation. Um, just want to take a larger step back to think about embodied carbon now, which probably when you all started this project wasn't, it was there in the background, but it wasn't a trend as it is now.
It is.
Uh, but in that sense, though, you had mentioned you thought through every material. Did embodied carbon kind of come up in your mind about, again, how much energy and carbon is really going in, not just operational carbon, like trying to select a material that saves energy over time and the utility bills, but how much does this material have an impact on the carbon? Did that like come up at all in the thought process of selection of product?
It does for me.
Yeah.
Like it's always something that having a background in environmental science that I've understood and we've always been pursuing, not necessarily to the level of documenting it, but being
Yeah.
conscious of it. Um, it's interesting because so I was at the awards presentation for the West Michigan, or I'm sorry, the Michigan ones back in December. And one of that discussions then was about the new LEED version that's coming out that will actually track that and where this carbon budget's going to be more important to that. I'm
Mm,
also about to start work on an LBC home where carbon budget's a significant factor and it's supposed to be tracked. So that being said, going
mm,
back to the time of this house, that's one reason that we use the dense pack cellulose is because it is a major carbon sink for us, as well as the wood
mm,
frame construction. Um, that as
mm,
far as other materials that go into the house, I mean, we would I'd like to see us get away from more concrete. And in fact, this LBC
mm,
home that we're looking at, we're going to try to do a wood foundation in. But
yeah.
um, the choice, you could try to pick your carbon sinks.
Mm,
The other thing is not just from the material standpoint, but the production
mm,
standpoint. The selection of the materials that go into the home and their carbon budgets is also a key factor. And I often try to explain this to the clients that we're working with that it's not so simple as just to select materials that say there's green. There's a lot of greenwashing going on here, and so it's important to
mm,
consider full life cycle assessments, that carbon
mm,
sequestration, as well as the production aspects of it too.
mm. Um, and there was a again thinking again about the embodied carbon, there was a question in here. Someone had said, don't circular homes actually use more material? I've actually heard the opposite, that circular homes actually use less material in just comparing if you were building it versus a square home. However, I've never been able to find any supporting evidence. It seemed like one of those things where someone just said it and then it just sort of scattered around, but you could never trace the source back. So, have you all seen or heard anything, or just in your own practice, do you feel that you used less material compared to the what I assume you're building more square homes?
I think that one thing I mentioned previously too is that we had a lot of stuff CNC'd. Um,
Hmm.
so because it's the curves that are going to result, the curves out of large, like a sheet of plywood or a sheet of
Hmm.
drywall that need to be cut. That's where the majority of the waste occurs.
Yeah.
So fortunately, in the case of the CNC, the waste didn't come to site. But
Ah.
not to say that there wasn't that waste. So when I mentioned that 32 uh, cubic yards of landfill, that's what we had to deal with on site. And
Right.
out of that, 15 yards of that was
Mm.
drywall. Um,
Okay.
so once again, taking large square sheets of drywall and having to cut curves out
Mm.
of them produced the most significant amount of waste of anything that was done on the house. But
Mm.
other than that, I mean, I don't know that it. I I can't say for sure. We make a practice of being very cost, or I should say, conscientious about the waste that we're producing and trying to find ways to dial that
Mm.
in. It's not uncommon for us to have houses with less than 20 cubic yards of waste. But
Sure.
I, as a general sense of whether the round versus the square was better, I'm not
Yeah.
sure.
Yeah, I'm not sure it's a black and white answer either.
Yeah.
It all depends on which material. Let's just
Sure.
acknowledge that most building materials are meant for
Mm.
rectilinear houses.
Mm.
Everything comes as a rectangle. So even to achieve
Mm.
the round look, takes some craftsmanship and thought to make it all happen. I think
Right.
mathematically,
Mm.
a round form is probably going to enclose more area or volume than a rectangular. So we could point to that as a plus side. But if all the materials coming to the job site are rectilinear,
Mm.
there are round plates now for stud walls to do curved walls. So slowly some
Mm.
materials are coming online to make it easier to produce curves, but still not as
Mm.
many as we would like to see because I
Yeah.
enjoy putting curves in our projects.
Sure. Um, the other question kind of there was a lot of questions here about the heat pump water heater and people noticing that in the pictures it was being I believe vented out, I believe exhausted out. And so if that's true, where was that going?
So we actually dumped that in a passive house. You're trying to avoid penetrations to the outside, so we don't want to be dumping any of our air out. You want to try to um, take advantage of hot air and move it to an area that needs cold air. So
Hmm.
that's, with the
Mm.
situation of the batteries, something that's producing heat to put
Mm.
it in a place that wants to take that heat. So we dumped the cold air off of the water heater to the laundry room for similar reasons. The laundry rooms were condensing dryers, and so you're generating a lot
Oh,
of heat in that room. And so, from a conditioning
yeah.
standpoint, you've got a hot room that you're dumping cold air into. Um, the only the
Mm.
thought was good, but you
Mm.
are heating water a lot more often than you're doing laundry. So there'd be times where the laundry room is cool, um,
Mm.
but it does work out for part of the time, and it does provide it so that we don't have to dump that air outside.
It's
Right.
certainly a fair trade-off to have a slightly cool utility room.
Yeah, and actually even the fridge
Mm.
is backed up to the laundry room and it has a vent on the bottom of it so that its heat is dumped from the fridge into that laundry room as well. So it definitely was a conscious design for that.
Okay. So the dryer is condensing and not a heat pump, correct?
Right. So once again, another penetration that we've eliminated.
Okay. Did you know why, just out of curiosity, why the heat pump dryer was ruled out, or was it considered
You're saying versus
versus
the
just straight electric condensing dryer?
oh, it is an electric condensing
It
dryer.
is.
But
Yeah,
but
it
is
is.
it a heat pump? Because usually a heat pump dryer, if I understand, will actually cool the room. If I understand how they work, maybe I'm misunderstanding them. Versus a
No, this is an
condensing
electric
dryer.
condensing dryer. So there's no
Right. So yeah, the question was a heat pump dryer considered, which I know are much more
Oh,
efficient.
I'm sorry.
Yeah.
No, I couldn't speak to the choice about that one. So
Yeah.
it could
Yeah.
be a cost factor. I mean, we looked at
Yeah.
a true heat pump water heater. As
Right.
Santa's making one of those, but the cost is
Expensive.
Yeah.
ridiculous. Yeah.
Yeah.
It's more
Well,
complicated as well.
Well, a good segue on that for the last question, and that is cost. And I welcome you all to answer the cost question in any way you want to answer it, in the sense of comparing it in relative terms or however you want. Obviously, everyone's asking the question, how much does this cost? How much does it cost per square foot? So, what I want to invite you to answer it in the sense like someone's going to do a project like this, you know, what is the comparison? Really, you're comparing it to the code, right? What is the bare minimum versus the code, and how does that play out? So, however you want to answer that, speak to that a little bit if you could. So,
Well, first, we're not going to talk dollars.
right, yeah,
Um, but I think the idea here is just to take the
mm,
techniques that were used and apply them to
mm,
other homes.
mm,
Obviously, the majority are going to be rectangular homes, which is fine.
mm,
We tried to make this house have some poetry to it by introducing the curves, and that was an aesthetic decision.
mm,
So, this project's not to tell the world that every house has to be round. That's not the case here. But every technique that is applied to this project
mm,
lends itself to any future build. So,
sure,
it was a little more expensive to build, of course, because of the
mm,
curves and having to use rectilinear materials in a curved fashion. Um, but,
mm.
again, this was all part of the balance and of what we were trying to achieve.
I would agree with Mark. I think that from as a
Mm,
builder, we all my homes have utilized very similar strategies. We've relied on high insulation values,
mm,
using a dense pack. We've been using the mini split systems. We've been using the
mm,
ERVs. We've been using the same water distribution systems and recirc pumps. So this is
yeah,
nothing that is out of the ordinary for us, and that we've already figured out how to do those things cost effectively. So
yeah,
I have other homes that we've done that are much more budget conscious that still
mm,
include all these exact same features. As a matter of
yeah,
fact, I have a house right now we're building that's a little over $200 a square foot and has all those same features. 12-inch
yeah,
thick double studded wall. I mean, we're not reaching quite passive house levels. I think
right,
we didn't run it through Woofy software, and we're not using passive house certified windows, which was that's a cost breaker.
right,
Actually, the LBC home that we expect to start, a little later this year, is we were debating about passive house for it, but the requirement for those windows is it just automatically throws another 15, 20 grand at the project. It's kind of tough to justify. You could throw another couple solar panels on and offset that and probably be more cost effective.
yeah. Yeah, no. And so would you say then maybe what I'm hearing is part of it is just the knowledge of these products, how they work, how they're coming together, and part of it is you say, you know how to do this, right? Maybe is it like more of a learning curve then for builders out there really to get to this level, having that knowledge and then getting over that learning curve really. Does that seem fair?
It's fair.
Yeah.
One thing that my company has that is probably a bit different than other builders is that we are not only are we the we do in-house the framing, and we also are licensed HVAC installers.
Sure.
The
Yeah.
two key elements of passive house have to do with insulation strategies, this heating and cooling budget, and the equipment that you're heating and cooling with, and the ventilation equipment. And they're
Hmm.
all things that are directly in the wheelhouse of my company. So
Hmm.
yeah, I mean, we have a lot of experience and a lot of knowledge base from time and working with
Yeah.
different manufacturers. Like we've used different ERVs, and we like
Hmm.
Mitsubishi equipment, but we've not always necessarily used vertical air handlers. That's something that we've been using pretty consistently over the last 3 to 4 years. But prior to that, we were using horizontally ducted systems or wall mount systems. And so
Yeah.
we've learned how to make these systems perform where we want them to, and at the same time find ways to keep making them more budget friendly.
Yeah. Yeah. Um, Well, with that, we are at our time. So I guess I just real quick, if people want to learn more both about this project and just about both of you, I'll start with you, Mark. Where can people go to learn more?
markmillerarchitecture.com will get you to our website, and you can contact me there if you have further questions or want to talk further about any of the topics we talked about today.
And
Yeah.
Paul?
And for us, it's Abueva Builders, just all one word.com, and
Yeah.
I take you to our website, and there's contact information on there as well.
Yeah. All right. Well, thank you so much, Mark, Paul. Thank you all for tuning in. We'll be here live again, same time, same place next week. So take care, all. Bye.
Great.
Thanks,
Thank you very
Brad.
much, Brad.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.